Hi dear students, welcome to Geeta's classes. In this class, we are going to see the first shifting theorem in Laplace transform. For that, we should know the basic function of Laplace transform, that is the definition of Laplace transform. That is L of f of t is equal to, we know that L of f of t is equal to, by definition, it is integral 0 to infinity e power minus st f of t dt. Means what? You are integrating, you are multiplying the given function with e power minus st and integrating from 0 to infinity, integrating with respect to t, and you are substituting the values for t, so it will be a function of s. Let us take it as f bar of s. So the resultant of this will be a function of s. Okay, that we denote it by f bar of s. So what is the first shifting theorem? The statement says that if L of f of t is equal to f bar of s, then L of e power at, that is the Laplace transform of the function which is multiplied by e power at, will be f bar of s minus a. That is, f bar of s minus a means what? L of f of t. L of f of t is always, remember, L of f of t is nothing but f bar of s, in which s should be replaced by s minus a. Okay, this is the theorem. So let us prove this. So we know that by definition L of f of t is integral 0 to infinity e power minus st f of t dt. So if it is e power at f of t, then by definition it is integral 0 to infinity e power minus st into whatever is there we have to write here. So e power at into f of t dt. That can be written as integral 0 to infinity e power minus st plus at f of t dt. So I can write this also as L of e power at into f of t is equal to integral 0 to infinity. I am going to combine this, that's all. So e power minus of s minus at into f of t dt. E power minus st plus at. So I am taking minus outside and t also outside. So this can be directly, you can write it as f bar of s minus a, because if you have e power minus st f of t dt, it is f bar of s. So if you have e power minus in the place of s, we have s minus a, so you can write it as f bar of minus s minus a, or you can substitute s minus a is equal to another variable x. So integral 0 to infinity e power minus xt f of t dt. What is this by definition? It is f bar of x. What is x? S minus a. So f bar of s minus a. If you have understood this, you can directly write f bar of s minus a also. Okay. So integral L of e power at into f of t. If the function is multiplied by e power at, without e power at, you find the Laplace transform and replace s by s minus a. Okay. That is there is a corollary, that is if the function is multiplied by e power at, f bar of s minus a. If the function is multiplied by e power minus at, then replace a by a minus a. From the theorem itself, L of e, we know that we have just proved that L of e power at f of t is equal to f bar of s minus a, right? So replacing a by minus a, we get L of e power minus at f of t is equal to, corollary means from the theorem we are going to prove the result. So f bar of s plus a. So e power at means f bar of s minus a. That is fine. Without e power at, you find the Laplace transform and replace s by s minus a. If the function is multiplied by e power minus at, without this e power minus at, you find the Laplace transform of this function and replace s by, you will be getting a function of s, and in that replace s by s plus a. That is the first shifting theorem. In the next class, we will see problems using the first shifting theorem. If you like this class, please give a thumbs up and please share it with your friends also, so that it will be useful for them. Thank you so much for listening.